Happy day, everybody. This is Orekoya Olusegun Physics Mathematics Fundamentals on YouTube. Please do not forget to subscribe to my YouTube. Also, share and click on the notification button to have more of my video. Today, I'm taking a topic that's related to both physics and mathematics, and that topic is vector. Like I've said in my other video, vector is a quantity that has magnitude and a direction. Now, today we are taking a topic, and that topic is derivation of vector equation of a plane and how to solve a related problem. Now, before we solve a problem, let me derive the equation of a plane. Now, let's consider a plane in 3D system in R3. A plane in R3, that is three-dimensional system. A plane that is describing in three-dimensional system. Now, let me have this an example of a plane. As you can see, this plane, let's say I have a point P0 taken on this plane, and then another general point P. And that general point P is described by the coordinate X, Y, Z. Then the point P0, initial point on that plane, is described by coordinates X0, Y0, and Z0. Now, let's say we have a perpendicular line on that plane. The vector for that perpendicular line, let it be represented by this vector n, and the coordinate of that vector is n1, n2, and then n3. So that's the coordinate for that normal vector. So now, let's say this particular point P0 on the plane has position vector, call it a position vector R0, and then it's tied to this origin 0, and this point general point P is also tied by this position vector, call it position vector R, to the origin. The position vector R0 describes the location of point P0, and the position vector R describes the location of point P. And then the normal vector is described by the coordinates n1, n2, and n3. This particular vector is perpendicular to the plane, while line P0, P, this particular line is parallel to the plane. Now, according to the relationship between a normal to a particular vector, let's say we have this particular normal to this particular vector, let's say this vector V. If they are perpendicular to each other, their dot product generally is equal to 0 vector. That is an established fact that when two vectors are perpendicular to each other, their dot product will be equal to 0. So we are still going to use this to describe the equation of this plane. Now, this number now that we have here is perpendicular to this line P0, P. So this is the sign for the perpendicular. Because it is perpendicular, we say this normal vector m bar dot the vector P0, P, P0, P. Their dot product must be equal to 0. Now, if you look at this vector P0, P, it's as if I'm moving from P0 towards P in this direction. As you can see now, I'm moving in this direction. If I want to move from P0 to P, I can equally move like this against the direction or the sense of a position vector R0, and in the same sense of the position vector R. R0 is a position vector describing point P0. R is a position vector describing any other point P on the plane. So, in a nutshell, my movement from P0 to P can be regarded to this movement from here to here is like moving against R0. So it's going to be minus R0 bar. Then it's moving in the same along the same sense as R. So you say plus R bar. That is this particular P naught P. So I can substitute what I have here to this place. But this one can be written as R bar minus R naught bar. This is a commutative law in mathematics. So I can substitute this particular vector P naught that we have here back into this vector equation. What I have here is the vector equation of a plane. Vector is a vector equation of a plane. Vector equation of a plane. That's what I have there. So I'm going to be working on this particular equation. So if I substitute what I have here now into this equation, I'm going to have the normal vector m bar dot, instead of P naught P, I will put this expression that I have here. That is R bar minus R naught bar. So everything will be equated to 0. Now, like I said here, the decomposition of n naught is given by this column vector. That is n1, n2, n3. That's the coordinate that describe this particular normal vector. Then times this R is the position vector describing this point P, and it can be decomposed into the x, y, z direction. So I have it as a column form as x, y, z. Then minus this R naught is the position vector describing point P naught, and that position vector is described by these components x naught, y naught, and z naught. So I will write x naught, y naught, and z naught. Everything will be equal to 0. So the whole of this now, I need to work it out. So I will write I want to rewrite what I have here. So I have n1, n2, n3 dot. I need to subtract this. So this will be x minus x naught. This is y minus y naught. And this is z minus z naught is equal to 0. According to dot product, we just multiply respective corresponding coordinates and add them together. So like this one, I multiply, add it to when I multiply this, add it to when I multiply this. So what I'm going to have now, I'm going to have something like this. If I multiply out this now, what I have here, I'm going to have n1 times x minus x naught. Then I will say plus this n2 times y minus y naught. N2 times y minus y naught. Then I will say plus this n3 times this, that is n3 times z minus z naught. Everything equal to 0. This is the vector equation of a plane. So we want to solve a problem, and the problem we want to solve is this. The problem says that we should determine the equation. Okay, let me put it here. We should determine the equation of a plane that passes through the following points: P 2, 1, 4, point Q 4 minus 2, 7, and point R 5, 3, minus 2. So we want to obtain the vector equation of that line. So I'll be on that plane. So what I'm going to do is to draw my diagram indicating the plane first. So this is the plane that we want to obtain the expression, the equation that will describe this plane. So this is the plane now. So on this plane, I have point P naught. Let me take it as that is x naught, y naught, z naught, which is given as 2, 1, 4 according to the problem that we have here. So, and the normal to this plane is this normal. The normal to the plane is this. So this normal now, normal n, I'll put it here as my normal. And then the plane passes through point Q. So the point Q is described by these coordinates 4, -2, and 7 that I have in this particular question. And we are told that the plane also passes through point R, and point R is 5, 3, -2. Now, the component of vector n is not given, so I will just take it as my n1, n2, n3, which is not given. So how do we find the vector equation of this plane? What we are going to do is just to take a general point P on this particular plane, and the coordinate of that general point, call it x, y, and z. And then, so in this case now that we have here, the general equation of a plane, the vector equation of a plane, is taken as the normal times the this particular vector that I have here, we cross to this other vector that I have here. So it's going to be n dot a cross, is going to be a cross b. That is the normal vector, this particular normal vector that I don't have the value for it. Now, how do we get vector a? If you look at this particular vector that I have here, you can see that it's emerging from here and going here. Then the vector that I have here is moving from here and going towards this direction. So what I'm looking for is this relationship and b. So what is our a? What is our b? The a, because it's emanating from this point towards this side, I'm going to find the difference between the coordinates that I have here and this coordinate. That's between the coordinate p0 and q. So to get this normal, normally the vector equation of a plane is actually n dot the line that I have here, going to be p0 r, vector p0 r. That's what is equal to 0. But this particular n is a cross b. So if I put this one here, I can have a cross b. Then it's going to be dot p0 r. The vector p0 r is equal to 0. So we are having the combination of cross product and dot product in getting the equation of this plane. So how do we get my a? It's going to be the difference between the coordinates of p0 and q. And the my b, vector b, that is this vector, is different between p0 and r coordinates. So what I'm saying here is that a dot vector a is going to be this 4 minus 2, then minus 2 minus 1, 7 minus 4. That is the difference in the coordinates of point q and point p0. To get b, is different between the coordinates of point r and point p0. So my a is going to be 4 minus 2 minus 2 minus 1, and then 7 minus 4, according to what we have here, this coordinate that I have here. Then everything will be equal to 4 take away 2 will give us 2, minus 2 minus 1 will give us a minus 3, and 7 minus 4 will give us 3. So that is vector A. Then for vector B, it's different between these coordinates that I have here. So we subtract the coordinates here from this coordinate. It's going to be 5 minus 2, comma 3 minus 1, comma minus 2 plus 4. So I'm going to have it written out: 5 minus 2, 3 minus 1, minus 2, minus 4. And then this will give us 5 minus 2 give us 3. Then 3 minus 1 give us 2. Minus 2 minus 4 will give us minus 6. So I've already gotten my A and B. So I can now substitute this A and B in what I have here. So this A cross B, the calculation of a cross product between two vectors, is actually given as the determinant of the coordinates of A and coordinates of B. So I will write the unit vector on top: I, J, K. So A cross B means you list out the A first. So it's going to be 2, this 2, then minus 3 and 3. Then cross B, the B is 3, 2, minus 6. That's 3, 2, minus 6. So we find the determinant of this relationship. How do we find it? So we say A cross B is equal to, this is plus, minus, plus. So let's start with I. A plus I, then determinant of, you cross this I horizontally and vertically, you'll be left with minus 3, 3, 2, and minus 6. Minus 3, 3, 2, and minus 6. We move down to J. The sign here will move from plus to minus. So you cross down the J horizontally and vertically. So we are left with 2, 3, 3, minus 6. So we move down to K. Since we have minus, the next one will be plus. Then we'll take the determinant, cross K out horizontally and vertically. We are left with 2, minus 3, 3, 2. Recall, if you are having determinants P1, P2, P3, and P4, to calculate it, we multiply these elements along the principal diagonal. That's P1 times P4. Then minus, we multiply along this second diagonal, P2, P3. So I'm going to use what I have here in calculating each of the parameters that I listed there to find the determinant due to A cross B. So that's what I'm going to do now. So I'm going to have this plus I. We multiply it because minus 6 times minus 3 give us plus 18. So it's going to be 18 minus 2 times 3 give us 6. So I'm going to follow that. This one's supposed to be minus J, and this one is plus K, the unit vector. As I'm picking them, I have to write them also down. So it's going to be minus J, then times minus 12, minus 9. How do we get this? Multiply minus 6 times 2, minus 12, minus 3 times 3, 9. That's how I got that one. So it's going to be plus K, then times, we multiply. So we are going to have 4 plus 9 in that respect. So this is A cross B. So when we work this one out, our A cross B, like I said, is the normal vector. So our normal vector will now be 18 minus 6. That's going to give us 12. That's going to be 12I. Then minus 12 minus 9. That's minus 21 times minus. That's plus 21J. Then plus 4 plus 9. That will give us 13. 13 times K. That's 13K. So this is the number that I'm looking for. And this particular number that I have here is what I'm going to use in this equation of the plane that I wrote here. equation of the plane that I wrote there. So now, so I'm going to substitute now. So what I'm going to have now here, I will now say therefore equation of plane is going to be normal dot p naught p. That is this particular normal dot p naught p that I have here, because this is what I'm looking for. So, and it's going to give us the same thing as normal dot p naught p is going to give us x minus 2, y minus 1, z minus 4. What I'm trying to say is this particular line here. So to find this vector here is going to be the coordinate of this arbitrary point minus the coordinate of p naught. That's what I did here. So everything will be equal to 0. Since I've gotten my normal vector, which is this, I can write it in component form. This is a rectangular form. Take note of that. Rectangular form. So I can write this in column form by just picking the numbers alone vertically. 12, 21, and then 13. I'll say dot x minus 2, y minus 1, z minus 4. I'll say is equal to 0. So now then the next thing we are going to do is to work out this expression that I have here, and that is going to be 12, 21, 13, then times the dot product times whatever I have here, x minus 2, y minus 1, z minus 4, which is given as, we use this, we multiply corresponding components. So this 12 will multiply what I have here, 21 will multiply the next line, 13 will multiply the next line. So we are going to multiply corresponding components. So it's going to be 12 times x minus 2, then plus 21 bracket y minus 1, then plus this times this. That's 13 times z minus 4 is equal to 0. So we work this relationship out. Again, the vector equation that I'm having now, the equation now will now be 12x minus 24, then plus 21y minus 21. When we open this bracket, we have this. When we open this bracket, we have this. 12 times x, 12x. 12 times minus 2, minus 24. 21 times y, 21y. 21 times minus 1, that's minus 21. That's what I'm working on. Then what I have here is 13 times z minus 4. This 13 times z minus 4. I'm supposed to have that there. So it's going to be plus 13 times z will give us 13z minus 13 times 4 will give us 52. We say is equal to 0. So the equation now, we are going to collect like terms, or these constants now, we combine them together. So minus 24 minus 21 and minus 52. That will give us minus 97. So the equation of this plane in the equation will now be 12x plus 21y plus 13z minus 97 is equal to 0. Or we can rewrite it as 12x plus 21y plus 13z is equal to 97. So this is the equation of the plane that is we are presented in this particular question that I have here. I believe that by all means you must have learned one or two things on the procedure, the algorithm of obtaining the equation of a plane, the vector equation of a plane in 3D. Thank you. Have a nice day. Bye.